Example 4 is a multi-step problem. It says you are helping to plan an awards banquet for your school, and you need to rent tables to seat 180 people. Tables come in two sizes. Small tables seat 4 people, and large tables seat 6 people. This situation can be modeled by the equation 4x plus 6y equals 180, where x is the number of small tables and y is the number of large tables. They want us to find the intercepts of the graph of the equation, graph the equation, and then give 4 possibilities for the number of each size table you could rent. Okay, so to calculate the x-intercept, we are going to plug in 0 as our y value. 6 times 0 is just going to be 0. When we solve this, we get that the x-intercept is 45. When we find the y-intercept, we're going to plug 0 in for x. 4 times 0 is 0. I get that my y-intercept is 30. So in the context of this problem, this x-intercept is telling me that one possibility for the number of tables I could rent is 45 small tables and 0 large ones. Another possibility is 0 small tables and 30 large ones. So that gives us 2 of our 4 possibilities for the third part of this problem. On this next screen, we already have the graph set up. It has title, labels, scale. So I'm going to plot my intercepts. My x-intercept was 45. Should be right here. And my y-intercept is 30. I'm going to connect these with a segment because I cannot have a negative number of small tables or a negative number of large tables. So I do not need arrows on the end of my line. All right, so the third part of the problem asks us to come up with 4 different possibilities for the number of tables that we could rent. So again, one possibility is 45 small tables and 0 large. Another possibility is 0 small tables and 30 large. And we need 2 more possibilities. So we could potentially find them on this graph, although when the scale doesn't go by ones, it's a little bit tricky to find nice points where they intersect. It looks like this might be one. 30 small tables and 10 large ones. We can check that by plugging it back into the equation. So 5 to 4 times 30 plus 6 times 10. Will that give me 108? It will. So another possibility is the point 30, 10. That would be 30 small tables and 10 large. See if we can find another nice point on this graph. It's kind of hard. This looks like a nice point though. The scale's counting by 2s, so this would be 24 small tables. And the scale's also counting by 2s. That would be 14 large tables. We can check that. So if I try 24 small, 14 large, does that work? It does. So 24 small tables and 14 large tables is another possibility. There are others. For this particular problem, you need to make sure you pick integer values. Every point on this line is actually a solution, but you obviously can't rent half of a table. So you need to choose values that would be integer values. One more thing, if you are having a hard time figuring out which ordered pairs work because of the scale of your graph, another thing you could do is rewrite the equation so that it solves for y. So I have 4x plus 6y equals 180. If I subtract 4x from both sides and then divide everything by 6, I end up with negative 2/3 x plus 30. This right here denominator helps me to pick some x values that would maybe work in this particular case. I definitely need to pick x values that are between 0 and 45, and I would pick numbers that are divisible by 3, because if I plug numbers in here that are divisible by 3, I will get an integer value when I work it out. So I picked 30 and 24 off of the graph, and they both work in the equation.